Welcome back to the Watch Track, where we're about to meet the experts at Cellular Highways to talk about the challenges and opportunities in therapeutic cell sorting. Cellular Highways is developing a new generation of automated high-throughput cell sorting instruments for research, diagnostic and therapeutic applications. Powered by a new microfluidic cell sorter technology, their instruments help to reduce the cost and complexity of cell sorting and achieve higher throughput than existing platforms, making cell sorting accessible to every laboratory. Make sure you pop your questions and comments into the platform, as we will also be having a live Q&A during this session. Don't hold back. Let the team know exactly what questions you've got, and the team will put those to our experts today. Speaking of whom, it's time to hand over to the Cellular Highways team of CEO Samson Rogers and lead biologist Laura Pinton.
We're all about high-speed, sterile, scalable cell sorting with a new technology, as you've seen on the right. There are various applications in biotechnology, but we think the most important is cell therapy, and that's what we've designed our first product around.
So let's start with a question that is also in our poll today. Which are the main challenges in cell separation applied to cell therapy? Well, we needed to maintain the sterility of the sample to perform a GMP-compatible cell sorting at a high speed with a good purity and yield, but at the same time being gentle with the cells. We needed to sort based on multiple markers and to do it in an automated way. Up to now, two main techniques have been applied that are immunomagnetic separation and fluorescence-based sorting. But both of these techniques have some disadvantages that have prevented up to now the combination of all these characteristics into a single technique. That's why we are working on a new solution.
So we'll tell you a little bit about the technology, how we've approached this challenge. Here's our core technology. It's a microfluidic chip made out of glass and silicon. And you can see, firstly, it's a single-way cell sorter. So you can see there's an input and two outputs, which we call sort 0 and sort 1. You also notice that there's no sheath fluids. There's no sheath input. Instead, there's this serpentine channel, which is an inertial focuser. Now, further down on the chip, you can see the sorting device itself. That's the new technology. Now, in there is something akin to a thermal inkjet actuator, so the same physics as goes on in, for example, an HP or Canon printer cartridge, except here it's employed to deflect a cell. Next slide. Oh, yeah. So this is how the core technology works. We call it VAX, Vortex Actuated Cell Sorting. That actuator makes a thermal vapor bubble, which doesn't deflect the cell directly, but creates a vortex, an eddy, at that tip in the flow, which you can see in the simulation. That flows downstream with a cell that we want and deflects it across the streamline. That goes to the ones we want go to sort 1, everything else goes to sort 0. The result of this is we have a very small, very fast cell sorter as our core device. And it's microfluidic on a chip, which means it can be made into a sterile single-use device. Now we've published 2 papers about the core technology. The first one is about the basic single-stream version, and the second one is about the parallelization. The whole reason of going down this route in technology of making a very small high-speed cell sorter is to be able to parallelize it on a chip and integrate it with cell sorting optics. So our cell sorter works with conventional cytometry, so fluorescence and scatter that's used by immunologists to gate and distinguish phenotypes of cells. On the right, you can see a comparison of our technology to the competitors, many of whom have also had this challenge in mind. It's a plot of size against speed, and you can see at the top conventional sorting. So conventional sorting, FACS, for example, is fast but also large, and nobody's been able to scale it by parallelization. Various microfluidic sorters have been invented in the past 10 years, some of them commercial, and some of them are approaching the speed of conventional cell sorting. We've got the smallest high-speed cell sorter in the world, and we've used it to build the fastest cell sorter in the world by parallelization. We call our products Highway 1 and Highway 16. Highway 16 is further off, but we're going to tell you more today about Highway 1, which is now close to market readiness.
This is Highway 1, our first instrument. It's a benchtop instrument, so it's small, and there's nothing below the table. It fits inside the biosafety cabinet. It has two lasers, the 488 and 640 nanometer, that allow to detect two morphological parameters, forward scatter and side scatter, and 4 fluorescences. In the final version, it will be fully automated, so very easy to use. The cell sorting takes place inside a single-use sterile cartridge that is composed of a 20 ml syringe, but other syringe formats are also available. This is the area where the sorting takes place. You can see inside here the chip. And there are 2 output tubes. In order to load the sample, you have also to strain it, and this is possible thanks to our inline syringe strainer. This is the research version of the cartridge, but we are already working on the GMP version that you can see here, that has 2 bags instead of the 2 output tubes. To start sorting, we have to load the sample inside the syringe and to apply the syringe to the cartridge and to insert the cartridge inside the instrument. Here there is a stirrer that mixes the sample in order to prevent cell aggregates.
So let's have a look at what you can actually see on the sorter, on the user interface while running the sorter. This is our alpha software, and in this example on the screen, this is what you see, sorting T cells, excluding Tregs. This is a sort based on 3 fluorescent parameters plus forward scatter, side scatter. Unlike in a conventional cell sorter, you actually see the cells going through the instrument. So there's a strobe microscope, and you can see an image of a sample of the sort events. Now, this is running in purity mode at about 20,000 events per second, of which 60% are cells. So it's similar speed to high-end cell sorting. Now, this is an example in enrichment mode, sorting of reticulocytes from whole blood. And in this example, because it's enrichment mode, we're going to much greater rates, so much greater than rates than people would typically run on conventional FACS instrumentation. This is about 45,000 cells per second. And again, this is two color cell sorting. And you can see a sample of the cell images. Third example, going to, again, enrichment mode, but extremely rare cells. This is a simulated CTC separation process, so spiked cultured cells in blood, in whole blood. And this is about 35,000 cells per second throughput, of which extremely rare 0.01% are the positive cells that we're sorting.
Let's see now some results obtained with Highway 1. You can see here in the first row the morphology of peripheral blood leukocytes gated by morphological parameters or by CD45 expression. You can see that both gating strategies are overlapping, thus meaning that the morphological parameters can perfectly discriminate the three populations. In the second row, you can see the 8 peak beads for the 4 different channels. We tested the Highway 1 on 4 different cell lines that are known to be sensitive to cell sorting, that are THP1, JURCAT, HEC293, and CHOK1. And we tested both cell growth, that is in the first row, and cell viability in the second row, of different conditions compared to untreated cells. You can see that all these conditions are overlapping, and this means that the cell sorting is not affecting cell growth and viability of these cell lines. We next performed a sorting in purity mode of immune populations from PBNCs. We sorted T cells, B cells, and monocytes, and the purity ranged between 93% of B cells to 99.5% of T cells. We focused in particular on the viability and activation of T cells. As you can see from the bar chart, the viability was very good compared to untreated cells immediately after sorting at day 0 and over 3 days of culture. Also, the activation was comparable to untreated cells after 48 hours of treatment with anti-CD3 and anti-CD28. Then we tested the CD4-CD8 ratio that was maintained immediately after sorting and over 2 days of culture. We then performed a different type of sorting in enrichment mode of T cells and reticulocytes from Buffy-coat or enriched blood. For T cells, we used a no-lyse, no-wash protocols. So the CD3 positive cells were 0.15%. And we achieved a purity of 75% and a yield of 82%, performing the sorting at 35,000 events per second. For reticulocytes, we started from 2.8% and we achieved a purity of 50% and a yield of 79%. But this time we performed the sorting at the maximum speed of 48,000 events per second. The purity here is close to the theoretical purity because we are sorting in enrichment mode. This means that the coincident events are kept and sorted in order to maximize the yield, even though the purity decreases. But if we consider the speed at which we are sorting the cells and the gentleness of the sorting, this sets the basis for a two-step sorting to be performed when we need to start from a very high cell number and to achieve a good purity. So what we achieve with the Highway 1? We can perform a sterile GMP-compatible cell sorting at high speed with a good purity and yield, but at the same time maintaining cell viability and function. We can perform a sorting based on 4 different markers, and in the final version, everything will be possible in an automated way.
So what you've seen today, this instrument, is a prototype, but it's now ready to put in the hands of users. We are really interested in hearing from companies and research groups that have an interesting challenge for our cell sorter. So where they haven't been able to get good results from existing cell sorting technologies. We have limited space for beta testing, so please get in touch with us as soon as possible. We intend to launch our instrument for sale middle of next year, but beta testing will start from around November. So if you're ready to test it, please get in touch with us. And thanks very much, and we'll be grateful for any questions.
Excellent. Thank you so much. Hello, everyone. Welcome to the live Q&A for this session. If you do have any questions for the experts at Cellular Highways, please do send them through the Q&A bar on your screen now. We do have a few questions here. So what type of collaboration are you offering to people who want to test it?
In the first instance, we are interested in beta users, particularly in cell therapy, where cell sorting is important. So there are quite a number of candidate cell therapies where the processing, manufacturing of the drug product is very difficult because it requires selection of a phenotype. And that's a use case that we think we can do better than any other solution out there. And so we would like to hear from companies like these who want to test it. We're going to supply our instrument for a short period free for testing because we want the data and we want the feedback. Users who wanted a prototype for an extended period will propose a loan and support contract until the commercial instrument is ready, middle of next year.
Excellent. Could you explain a little better how the sterility of the sample is maintained in Highway 1?
Well, the cell sorting is performed, as I already said, in a single-use sterile consumable. Of course, the sample should be loaded inside the syringe, but if the sample is loaded inside the biological safety cabinet, the sterility is maintained. Also, the instrument is compatible with the biosafety cabinet, so everything could be performed in sterility if needed. Moreover, I would like to underline again that there is no sheath fluid that is a source of contamination, so sterility is maintained in the end.
Excellent. Is it necessary to be an expert in flow cytometry to use your equipment?
Well, for the first users, we will prioritize people expert in flow cytometry because we would like to have a feedback from these users. But our final user doesn't need to be expert in flow cytometry because the instrument will be fully automated, so very easy to use. So just a very basic knowledge will be sufficient to perform cell sorting.
Fantastic. When will Highway 1 be available for purchase? And what about Highway 16?
Right, well, thanks for the question. So we're aiming for launch summer 2022, commercial launch. So available for, to purchase from the coming summer. Now, Highway 16, our scale-up version, is currently a lab demonstrator. We've started proper product development now, and we anticipate beta testing from 2023 and launch 2024.
Excellent. How does the speed and performance compare with other conventional sorters and the Miltenyi Taito?
Mm-hmm. Yeah. So for many purposes, our cell sorter, Highway 1, has an equivalent speed to high-end fax. Sorting 10 to 20,000 events, or 10 to 20,000 cells per second, depending on the mode and the type of cell. So for blood cells, we typically do 10,000 per second in purity mode, or up to 50,000 per second in enrichment mode. That in purity mode is similar to conventional sorting. In enrichment mode, it's a lot faster than people normally do. The fast enrichment mode also has the advantage that it sets us up for a good two-stage sorting of rare phenotypes. So where the first stage is enrichment mode, second stage is purity mode, and putting them together allows us to achieve much greater throughput for purity mode. The reason you can do that on this cell sorter, but not on conventional instruments, is that it doesn't compromise viability. Now, the Miltenyi Taito is, of course, the first sterile cell sorter that's available, currently a commercial instrument. For practical cell sorting, we're a lot faster than the Taito. We think we're about 5 times faster in purity or enrichment mode than anybody actually practically achieves on the Taito, that is.
Fantastic, excellent. Thank you so much for your time today. I think that's around all we've got time for. If you do have any further questions for the Cellular Highways team, please do reach out to them on the GRIP platform, and I'm sure they'll be more than happy to answer your questions or arrange further meetings with you. Next up, we do have a spatial chat networking, so please do join that. Thank you again, Samson and Laura.
Well, thank you. Thank you, David and Ryan.
I'll hand back over to David. David.
Thank you very much indeed, Ryan. And yes, thank you, Samson and Laura. Do make sure that you check out Cellular Highways booth profile via the event platform and chat further about their really interesting, innovative technology. Up next, we have our Tea and Tech session, which is hosted with the support of Pole Corporation. Head over to the networking track for a technology demonstration from Pole, and also get mingling with your colleagues via, as Ryan just mentioned, a spatial chat. Not special, though it is very special. It's a spatial chat. So make sure your audio is turned on for that session and get involved in group or individual conversations. See you shortly.